Today, on Guess What I Found Out, we're going to discover some facts about LIGO, the giant laser ear that can hear the universe wobble, also known as gravitational waves, or, well, space-time doing Pilates without asking permission. So, how did we learn anything about the universe before LIGO? Mostly by looking, light, radio waves, particles drifting into our detectors. LIGO adds a new sense. It's like humanity went from "I can see the jungle" to "wait, I can hear something breathing behind me." Here's the idea. Einstein's general relativity says massive objects warp space-time. That's gravity. And when huge objects like black holes collide, they don't just make light, they send out ripples in space-time, gravitational waves, traveling outward at light speed. The problem is, those ripples are tiny, like absurdly tiny. So LIGO is basically a hypersensitive measuring stick built from lasers. LIGO shoots an infrared laser, splits it into two beams, and sends them down two perpendicular arms. The beams bounce between mirrors and come back, then recombine. If both arms are the exact same length, the waves of light cancel in a way that produces almost no signal at the detector. But when a gravitational wave passes through, space-time stretches one arm and squeezes the other, just a little, and the recombined light shifts. That shift shows up as a tiny signal, a flicker, a chirp on a chart. And yes, these are 4-kilometer arms, so long they even account for Earth's curvature. Because physics is never satisfied until it's mildly inconvenient. Curious George, if you love science, that's basically, we measured nothing, and that nothing told us everything. Inside those concrete tubes is a beam pipe with an extreme vacuum, because stray air molecules would mess with the laser. Then there are the mirrors, the test masses, 40-kilogram fused silica optics, built to interact with the infrared laser and coated to reflect the beam extremely efficiently. And vibrations are the final boss. The ground is, well, always moving a tiny amount, and LIGO has to isolate the mirrors so well that local noise doesn't fake a cosmic signal. This is why LIGO has a legendary noise-hunting culture. Now, for your impromptu survey, because we're classy like that. Team A. The worst enemy of precision science is trucks and earthquakes. Team B. The worst enemy is birds with opinions, like ravens, pecking stuff for fun. Pick a side in the comments and make your best argument. If you choose Team B, you must defend the ravens like they're your chaotic little interns. Here's the brutal part. Early on, LIGO ran and saw nothing for years. Then, advanced LIGO upgrades improved sensitivity, and in September 2015, a signal showed up, the first direct detection of gravitational waves, known as GW150914. It was announced publicly in February 2016, and it matched a model of two black holes merging far away. And here's how they knew it wasn't. Like a suspiciously timed pickup truck, there are two LIGO detectors, thousands of kilometers apart, and both saw the same event. Curious George, if you want more, the universe is loud, but we just built ears content because this is the era of space listening, and it's only getting weirder. Scientists are pushing toward next-generation observatories, including plans like Cosmic Explorer, which proposes much longer arms, on the order of tens of kilometers, to hear deeper into the universe. So yeah, Curious George, the universe has been stretching and squeezing space-time this whole time, and humans finally built a laser ruler sensitive enough to notice. If you've got any other fun facts about LIGO, gravitational waves, black holes, or any science shouldn't work, but it does moments, drop them in the comments. I want to see what you've got. Also, check our page for the growing collection of fun fact videos, because your brain deserves better than doom scrolling and microwave conspiracy threads. Subscribe, and I'll show you what else the universe has been whispering while we were busy arguing online. And trust me, the next one gets even more unreasonably cool.